clear prop.
So I hope you guys stick around and join me in this video for some instruction on how to install a gas engine, fuel tank, and all the stuff necessary to get you going on your balsa ARF. Also, follow along in this Zero build series. That way you get to see all this cool stuff and how we installed it. Today, we're at the step where we need to install our EME60 with AutoStart in this 86-inch giant scale Zero that I picked up over at Gator-Rc. This is a Seagull's model balsa ARF build. Where we are in the process right now, we've completed the tail, the wings are done. Let's get to the engine. In this step, it shows you that all the fueling system stuff should have been in and installed. I prefer not to do that yet, as I don't want any of that stuff in the way. And as we're doing wood cutting, I do not want any of that debris flying around near the engine or fuel system. So this is what we have laid out as the EME60 with AutoStart. You can see the AutoStart feature there. You do need a relay in order to power up the motor and a separate LiPo battery. It comes with an electronic ignition, comes with a side canister, which we will not be using. I did pick up an optional pit style muffler for this plane. It does come with a CM6 spark plug for this thing. Those came with the pit style muffler. It gives you a short pair of standoffs, power wire, and some conduit or convolute, and then the nuts, bolts, and washers that are needed in order to get started on the engine. Now there's a couple ways to go about installing this engine. Number one, you could check the link in my other CARF build in which I used the steps method in order to place and center the engine in the cowl. The other method is what we are going to use here, and this on the Seagull's model. On the firewall, they actually have it marked off for your down and right thrust, and you could see the difference in the firewall box right there. Everything here is already sealed, and they have a like a fiberglass reinforced plate there for you. So what I've done here is followed the marks they already gave you by using a builder's triangle. I went ahead and I just marked those off all the way across. This stick comes as a reference from in the book where they show you need 170 millimeters clearance from the firewall out to the edge of that where the prop's going to bolt on. So what I do as a reference, just to see how long I need, I go ahead and cut a stick to length and I place that on there. So this is supposed to be 170 millimeters from there to there, which it is. When we look at my engine placement, that means that I need to recess. If you look at the edge of the prop hub right there, I actually need to recess back in probably about a 1/4 inch into that firewall. So in order to do that, I got to take that hole and open it up. Again, why I don't want the fuel tank or anything else there. So that stick is just simply there for a rough idea of and a reference, so I don't have to be trying to hold a ruler or a tape measure or something like that. From here, I'm going to go ahead and make a template or a cutout for the back of this engine, and make sure you label it as I have top and firewall, so that way you don't get it messed up. And following the bolt patterns right there, that's the cutout shape that I would need to give me some ample carburetor clearance. Now I am going to start small, and all I've done is take this template, flip this around, and I've placed it right there with those marks. Now where did I get those marks from? I simply measured the distance between center to center and marked it off on this base all the way around. So as my template was sitting there, I just transferred the measurements, and I know that goes firewall side, top side. And when I set that there and I line everything up and I match it, then I know where my carburetor pattern is. And basically what I'm going to do is start working towards that. I'm not just going to cut right into there. I am going to cut towards those borders until I have the shape that I need. When we're all said and done and the fit's right, we're going to make sure that those mounting locations are exactly where I want and drill those. That's one of the biggest items. You can make that center as big as you really want to, but these we don't want to make any bigger than need be. When that's all done, you've now exposed a lot of fresh wood. We want to make sure we mix some epoxy and some alcohol together. It doesn't take much alcohol to thin the epoxy down, and the more you thin it, the longer it's going to take to dry. So just enough that it gives it a liquidy consistency, and you want to seal off anything that's new in there for wood, because the last thing we want is fuel and gas mix to soak into there. But otherwise, right now where we are is we're ready to get cutting, and once we have that distance there, then we can worry about our standoffs. But I need that distance or that clearance for this thing to set in there before I start worrying about standoffs. So let's get to cutting. It turns out that it looks like these standoffs are actually going to be the perfect size for this engine. On the AutoStart side, if you ordered it this way, it's already going to have 2 lock nuts on the AutoStart side. So we're basically just going to go ahead and remove those, and then the standoffs will thread on just as you see here. Now don't forget. So now what we're going to do is we're going to go ahead and drill those 4 holes. That all looks like it lines up. Looks like I'm going to have plenty of clearance. I didn't go all the way out to all my corners, but I did have to go a little further in some. But again, you can't use too big a washer on the back side. I would use up whatever space you have to pass that load around. Once we have all those drilled, then I'll take everything, make sure it lines up. And then once I have them drilled, I'll take those bolts out, and we're going to coat the inside and seal those and seal this off, and probably let it dry overnight before we come back. So let's get to throwing this engine on. Now we're going to go ahead and install the engine. We're going to get the longest bolts that we can get in there, and you're going to put the fattest washers you can possibly get on the back side of that firewall. So on one side, that's as big as I'm going to get, and the other side, now these are called fender washers. These are 10/32 bolts and 10/32 fender washers. We're going to go ahead and place those in there. You don't want those things to ever pull through or pull out, and that gives a lot of support on the back side of this firewall. And again, we're using not only those fender washers, but we're using lock washers as well. And even after we get this stuff in, we are then going to put on some red Loctite. And the red is a little bit more heat resistant than the blue. I should say, you can look at it as it needs heat to get it apart. And the thing about these bolts, I've had bolts come loose on me. One of the first gas engines I've ever put together, I had an issue with it, and it wound up coming loose, and that's not pleasant when your CG changes and the engine's half fallen off of the firewall. So we use lock washers, we use red Loctite, and that way we don't have to worry about the stuff coming loose. And then the other thing is sometimes I'll even go through and use high temp silicone on the back side. Now I've gone ahead and taken my standoffs off just so I get everything here rolling. It just makes it a tad bit easier if you put everything together loosely and then tighten it up as you go. Now as we go to put the motor on, we're going to go ahead, I hate that word motor, by the way. If it's an engine, it's an engine. If it's a motor, it's a motor. But I still catch myself doing it. A little bit of Loctite on the bolts that are going to hold this on my standoffs, and putting everything together loosely. Lock washers, big space, lock washers, big washers. So that way we know that everything's going to stay together. And now that you have all of your bolts started, so basically all 8 bolts started, we can just go ahead and snug this up. You do not want to draw this engine on crooked, all right? You're not doing this to account for misalignment, because what will happen is everything is this cast aluminum, and I'll guarantee you that's going to end badly. We're just going to work our way around, snug them all up evenly. And here's our mock-up. This is going to be a pretty decent fit. I like the cut again all the way around. We have access to our choke lever here, plenty of room for our throttle, and then the only thing is, if you guys can see that fuel inlet can't even get my finger in there, right there. I am going to have to open that hole up a little bit so the fuel line comes through and it's not being bent too hard or pinched off or compromising that fitting. But again, this is why I prefer to build the tails first. That way it gives you a little bit of counterweight as the thing's sitting here on the stand. Your other alternative is to bungee across the stand in order to get that thing to stay on there. So that's our Pitts muffler and the way that that thing's going to look. Now what we're going to do is remove the muffler, and it's time to mount the cowl. And that's going to be one of those processes you want to make sure that you take your time and you get right. No sloppiness there if you want a clean cut cowl. But basically we're going to take a template and we're going to tape it onto the plane and drape that cardboard or paper template over the engine and literally try and notch as closely around on the paper as we can. Pull the engine off, put the cowling on, and then you're going to go ahead and cut that. So there's a lot of things that come into play because we also have to cut this thing and put that up in the inside. And I'm only going to cut out the part here around the cylinder head because I just want to force the air in right over those vents and just kind of drive it through there and then out the back. But anyway, let's get this off of there, the Pitts muffler off of there. Let's open that fuel end up a little bit. We can start to put our paper on there. We'll take that engine off and then we'll open up that fuel thing. But got some work ahead of us yet. We're not quite there, but looks good with an engine on it. Man, I love it when something turns out awesome looking. Look at that radial engine in there. That looks phenomenal. I love it. It's very cleanly cut. The spacing on everything fit absolutely perfect. So we're not even going to see that rough trimming there. And I don't know, maybe I'll even open that up a little more. It doesn't much matter. But what we did here is we went ahead and we took a aluminum enamel and we painted all of the cylinder heads the aluminum enamel. The tubes we left that color, and then we went ahead and took some olive drab, and while the aluminum color was still wet, we smeared in some olive drab to cover the cylinders. And while that was all drying, then we wiped in some of this acrylic, this is burnt umber, so it gives you a very nice rust color, and we just smeared that in places. So we get a very nice kind of rusted, shiny undertone to those fake plastic radial engines, and then we took some just regular red wire, made some holes, and simulated our spark plug wires for that thing. Now, check this out. So first, I just want to make sure that I show you guys. This is the 2-blade spinner that comes with it, and although I wanted to go with a 3-blade, I just want to tell you about how well or nice this thing is made. This back plate will actually sit nicely and almost very flush to that back surface of that radial engine. So all the numbers they give you in the instructions are spot on. But I'm like, oh man, look at that big gap that's in there. Well, they go ahead and they place those two shims over the top of that bolt, and then they put on your adapter nut in case you need one of those, so that way you don't lose the shims. But look at this. So on the back side, this one is shouldered, and that one fits perfectly on the inside of there. And in case you have a smaller diameter shaft yet, there's another spacer that perfectly mates in the inside of that one. The ability to get all that stuff machined perfectly on center and not have any play is amazing. This is an amazing quality spinner that comes with this plane. So if you wanted to go with a 2-blade, that's perfect. But I am ecstatic with the way that this engine turned out, cowl mount wise. It is time now. We are done with the outside. I am waiting on my 3-blade spinner to show up. Let's get into the fuel system. I'm going to show you guys what we are going to do to modify this fuel tank and to make that a little better and get all of our linkages installed. This is getting awesome. We're getting close to having like completion feelings here. Like, oh my God, we're making progress. Let's go. What do you guys say we build the fuel system for this Zero? Clear fuel tanks, absolutely love them. Now, two things. Number one, square tanks have been around forever. Opaque ones that you can't see through have been around forever. And they work just fine. With that being said, see-through is a step above. Why is see-through a step above? Because the biggest issue you have is that clunk that's in the inside of there. That hose tends to break, and you wind up with an issue where your plane may run good sometimes and not other times, and you can't see that that clunk is broke. So now that I could see in the tank, that's a major plus. Now, theoretically, you can actually roll this thing around to certain positions where that clunk isn't always at true bottom. And you're going to see 1,000 ways to skin a cat here, guys. That's really the truth. But I'm going to tell you that if you opt to go with, I could tell you Gator-Rc has a selection of round fuel tanks. It's the same shape no matter what orientation you're in. So thus the advantage of round tanks over square tanks. So you could pick some of those up, check them out over at Gator-Rc as well. This airplane came with a square tank, and that's what we are going to use. And I'm going to show you some of the modifications that I do to this thing to help have success throughout a lot of flights. And we're going to try something new. So the first thing we're going to do is we're going to open up this tank, and you are going to see that there is an O-ring seal in there. Sometimes those things aren't exactly in the groove, and we need them to be exactly in the groove, otherwise they come out. I don't use these yellow lines because this tygon tubing, if we can get that off of there, tygon tubing tends to get hard and brittle over time. And you may get a season or two and the stuff will get hard. And that's a problem when you start rolling into different positions or you start running past that level of fuel. So what I like to do is take this tygon tubing out. And I've tried different fuels and stuff before, and also that's just a straight unfiltered clunk and it works well. I don't use it. You have a bunch of extra seals and pieces in here. We're going to take those out, and as well a clamp. These fittings, typically the vent is the one without any hose. All right, so as we fill, this thing is, believe it or not, full all the time. It's all the time. It's full right now, just full of air. When we go to fill it full of fuel, we have to push the air out, so thus you need a vent. When we start to take the fuel out of this thing, we need to let air in, otherwise we create a vacuum. So expansion and contraction principles in play there. A couple things that I want to note to you. So number one, this doesn't have to stay in this orientation. So most guys, including me, we like to make loops around the top of the tank to create an air bubble pocket, so when you roll inverted, it doesn't spit fuel out. This doesn't have to stay in this orientation. You can go ahead and just kind of turn this whole gamut the other way. And you also want to check these to make sure these things stay tight, and that's why I always go in a clockwise direction to make sure I'm actually still making them tight, not loose. Here's the downfall of these tanks. This is definitely a problem. If you look at that pickup and fill line, that's the one with the hose right there. On tail draggers, guys, that thing's bad news. And I'm going to tell you why. Because the tank sits like this. So if you have a quarter of a tank of fuel left in there that you landed, you're going to go home for the day, you don't leave fuel in the tank, you always in and out. Always take your fuel in and out and run it dry. Never leave any fuel to gum up your system. That tube will not allow you to actually take fuel in and out of this plane in a tail dragger in this state. So every time you want to take fuel out, you got to tilt the plane this way. The other thing that we can do is actually make that hose longer and fish it towards the back. And I like to cut that, if you can see that little chamfer on the fuel there as well, that line, because you don't want the thing to suck itself to the bottom. And that kind of prevents that. Now, what are we using for fuel line in this thing? I am going to use FluroSilicon from McMaster-Carr. This stuff is touted as some of the best fuel line out there. Now, it is high temperature fuel resistant material. The problem is you can't see through it to know if you're siphoning fuel in, but I think I may put maybe a clear section of hose somewhere along the way so that way I could see it. Now this is, I think it was it's quarter inch total diameter, 1/8 inch inside diameter fuel tubing. And what we're going to do is I am going to actually take that tygon piece of tubing, and we're going to take that out and we're going to replace it with a piece of this and see how this works. This is my first time using this. I've heard good things about it. It's on the expensive side. It's a couple bucks per foot, where tygon is obviously not near that price. And here is what I'm going to use. These are ceramic filtered clunks that you can get. They're like Briggs & Stratton and steel clunks. You can get a pack of 10 off of Amazon. And I am going to use this on the inside. So that way I have my fuel tank, my fuel can that I fill in this. This has one of these in that as well. So all the fuel is filtered in and out of the can constantly. The fuel that's being sucked out of the tank is filtered. So now we have double filtered fuel system. If you want to put an inline filter in there as well, now you have a 3 times filtered fuel system. So the odds of getting dirt in the carb are really, really minimal. So for now, we're going to go ahead and take that out, and we are going to get the right length tubing installed on the inside, and then get this clunk close to the back of the tank, and hopefully it's not going to rub, and we'll leave a little room. I might have gotten burnt on one of these before with some other blue Tygon-ish fuel tubing that expanded and caused some issues, but we'll see. I had a couple planes that didn't cause an issue and one that it might have. I don't know yet. But anyway, another thing that I want to show you is how to make clamps. A couple different clamp methods. We can use a metal clamp, nothing wrong with that. You can use a zip tie, nothing wrong with that. Or you can go ahead and cut yourself a piece of this tubing right off the end, and you can make it a little wider, you can make it more narrow, whatever you want to do. Anytime you cut fuel tubing, believe it or not, people have done studies on this, you want to use a sharp X-Acto knife to cut fuel tubing. Do not use a pair of diagonal cutters. When they break it down under a microscope, they show you it frays the ends and creates little cracks. So if the fuel line hardens, that's what tends to split it going up the sides. So I'm going to take this piece and I am going to put it over a set of expanding hemostats. Again, if you don't have a pair of these things are awesome. And we are going to place that over the tube there. And we are going to get our ceramic clunk and push that in, and then make sure our clamp is right there. Now, depending on what fuel tubing you're using, if you're using Tygon or glow fuel, you really can't even pull that apart. If I pull on this new fuel tube hard enough, that stuff will actually pop off. Here's the thing. So just for testing purposes, we can go ahead. That actually hurt. So I don't know what more you could put that through in the plane and it's not going to cause any issues. And that's still exactly where it was. So there's no doubt in my mind that strength-wise, we're completely okay with this. So let's get that installed in the time lapse. All right, now you can see that we have our fuel tubing installed. We have our ceramic clunk. Again, take a look at that O-ring there on the inside and make sure that thing is firmly seated down into the groove. And that way you know we're not going to have it pop out. Once it's down in there, drop it down into your tank and thread it on nice and tight. So you can see this thing will bounce around with that other tube in there, but it's not going to lay on top of it. It may flip places with it or anything, something else. Now, there's guys that like to put brass tubing in there so the thing doesn't flip around and go back the other way. Sometimes people say if you hang your plane upside down by the tail, it causes issues. Again, a million ways to skin a cat. I've always had good success with this. Now, here's the other secret for this portion of the seal. Now, this is 3-inch wide, 1.5, 3.1, yeah, heat shrink. So this is 3 inches heat shrink. We're going to take a piece of this and we're going to cut it. You don't need a ton, maybe about 3/4 of an inch. And we're going to take it, again, make sure your cap's on there nice and tight. And you can see your O-ring on the inside. If you look down in the inside through the tank, you know if you got it wrong. And we're going to take this piece of heat shrink and we're going to slide it over. And that's what we want. We want to see some of the lip. And now we're going to get our heat gun. Now this is going to do two things for us. Number one, it's going to make sure that lid, it never comes loose, but also it's going to make sure that it's sealed, so it never is going to leak around that O-ring. And as this is shrinking down, I push it down so it stays on the lip of the tank. Then we'll seal it up towards the top. There you go. So that thing, even if there's a little fuel down there, will still pick up right up through that corner. And like I said, it can flop around in there with that hose. I've never had any issues with it. I guess if you wanted to, you could put another clunk on that too, but maybe that causes issues. But that won't bother me at all. That thing's going to be perfect and good to go. Let's get to installing it in our plane. When it comes to mounting your tank into place, again, a little bit of foam there is always best. Having your tank secured is very important. We are going to make a loop on the vent line here over the top of the tank there and going down. And on the bottom, I'm going to use these cool little press-in valves. What's neat about these valves, these are on the bottom. You're going to put this in the body, you're going to hook your fuel line up to it, and then that's your vent. So when you go ahead and fill these things, you can actually catch it, catch the fuel coming out. Some fields have an issue with any gas hitting the ground, which isn't great for the environment. But anyway, to fully seal off your fuel system or prevent any goop or drainage or leaks or anything else like that, you can simply just put that back in and the system is more or less sealed back up, short of what's open in the carburetor, I guess. But I like those things. A little cheap gadget to put on the plane. Very inexpensive, and they work real nice. The fuel lines themselves are going to get hooked from here down to, as we said, our fitting on our carburetor there. Ideally, you would like this thing level with the carburetor. That's the ideal setup, and we're fairly close, even just a hair on a downline, which is perfectly acceptable, and it's probably to our advantage because the fuel that's in here will help to feed the carb. You run into starting issues when you go from here uphill because now you got to get that carburetor on an empty system to suck the fuel going up, and it's a little bit more miserable to get a gas engine to start. So besides that, we're going to go ahead and get everything clamped down. Again, my filler, I'm just going to simply have an open hose here with a connector shoved in the end of it, a little fuel barb, so I can pull it off. If you wanted to, you can get a little bit more elaborate and put a fueling dot on the inside, but why would you ruin a perfectly nice, till this is done, will look as scale as Brendan's going to get one. Why would you kill it with a big fuel dot here on the outside if you don't have to? when you have access, let that hose long enough so when you fill it, you're filling it out here. Don't make the mistake of making it short and trying to fill in here. We don't want to fill in here. I want the filler line though in here, so that makes sense. Let's get to it. A lot of work to do. So we have our fuel tank secured. We have our vent line wrapped for right now until I determine when the cowl's fully on the exit for the vent. We're just going to leave that extra tube hang here. And like I said, there is my fill. So we have enough length to hang out over the side to fill this thing. And for now, we're just going to tuck that in the way. So I'm pretty happy with the way that looks. We have our ignition module mounted and secured in there. It's time to run the leads now going off of there. So what we have for the leads are just some simple slide-on ends that you can pick up over at Lowe's or the local hardware store. And we're going to be routing 14 gauge wire through some convolute, this flexible wrap stuff, this braided stuff that you can get off of Amazon and stuff. Works really well. And we're going to run that along with the ignition power in through this port, and we're going to travel all the way around the inside of the plane through that channel and wind up coming over, and we will feed off of the relay, which will be powered by a 3-cell 1000 milliamp LiPo. So we're going to run the ignition and the starter off the same LiPo battery. I've notched the inside here of the housing where we're going to recess this whole module down onto the inside, so I can still plug and unplug out of it fairly easy with a couple different connectors in there for my so I can unplug out of there for my power system. But that gets me out of the way and frees up some more space in here for other things. And as I said, we will wind up installing our battery backup system, and I'm going to mount my receiver over here on the side, and chances are this JP brake controller is also going to be fished right here on the inside, because it will also be powered off of that LiPo. The only thing that I really want powered off my receiver on this plane will strictly be all the servos. So we're going to go ahead and get to that. Let's do it. It's time to choke it. Anyway, if you guys can see way up in the inside of there, that first plate you are going to see in the back of the carburetor, which, I don't know, maybe I hope you can see that way up in there. That's going to be our choke plate. Our choke plate is either an open choke plate or is it a closed choke plate. We don't run anywhere in between. We will set that up there. So all you simply have to do is watch your choke on the inside and see what it does. I'm trying to set up right now this throttle servo. And what we want to do is you want this again in the biggest resolution possible, because you want to actually feel the steps of the throttle going all the way up and down. You don't just want to go just 2 clicks and have it go from idle to wide open throttle, and that's what happens when you don't maximize the resolution coming out of these servos. On the throttle, I'm only using a 5514. I don't need as much torque as the 5523s there, but with this thing I might have to go a hole out from the inside hole to maximize, because I think I'm a little short in the throw, and you don't want to set the servo arm so it's actually like coming all the way on the backside. I want to set my throttle up first, and then I am going to set the choke up so the choke's open or closed. And here's how you can cheat also with your throttle. So as I operate my throttle, you can see that's going to be my idle screw right there. That is what I am going to use to control the open and close point. Now, honestly, this is just a big stopper for the lever. You can honestly go ahead and take that out if you really wanted to. A lot of engine guys prefer to take those out, so that way they don't have a physical adjustment stop for that idle. I set mine and it's usually just fine. And then as we go to wide open throttle, if you guys can see that little lever right there, it actually has a stop where it's going to hit on that metal bracket. So I can see here, I don't actually need to look in the throttle plate as long as I know my lever's going the right way. I just need to set my servo throw so it rests perfectly on both of those ends. And again, set your throttle trim into the middle. So we're going to make sure our throttle trim is in the middle as we adjust this so we can go up or down with our idle. Again, I'm going to be using an RPM sensor here, so I'm going to be able to keep a good accurate eye on my idle. We have the AutoStart, and we're going to have an auto choke. This is shaping up to be quite the project here. But anyway, let's go ahead and adjust those servos. So what we're going to do now is we're going to take our spinner back plate, and I'm going to drop that little shim or spacer into the back. And we are going to take our alignment tool, or a drill jig as they call it, and we're going to place that through the spinner back plate and drop it into the prop. Now, these are very specific metric sizes, so I encourage you guys to get the right size. I want to say they were either 5 and 10 or 6 and 10 millimeters in those drill holes, and that will help you immensely to figure things out. And then I also am going to tell you to definitely get yourself a bolt and run it down through the other end to snug things up. That way it just prevents stuff from moving and moving around. So what I'm going to do now is I can flip this thing over, and I'm going to look for the marks on my spinner there, and we're going to match that up where I wanted it. And this drill jig we can simply turn into position and then make sure that that thing is, again, nice and tight on the other side. There. And now we are going to take this over to the drill press, and we're going to go ahead and drill straight down through there because everything is lined up. It should go fairly easily, and with the drill press be a nice, straight, perfect drill. So let's get over there. Now, we're going to go ahead and take that bolt out of there. I was holding everything in a line. Take our drill jig out. And when I dedicate drill bits to these prop jigs, I don't use them for anything else. That is literally all I use them for. And I leave them with the drill jig, so they may sit there for years before they ever get touched. So we're going to place that thing back on the back. We're going to line up our marks there. Now we're going to go ahead and slide this on. We're going to line up those marks. We're going to get our nose plate, and I'm not putting the cowl on for right now. I won't do that until after I've fully test run everything and made sure that everything is tuned the way I want to. That tune the way I want it to run, that all my sensors work, my RPM sensor, my temp sensors, and everything is exactly right. Then I'll put the cowl on for a final and know that I am done with it. When you tighten these up, we're going to tighten up one side. And then we're going to tighten up the other side. So we're going in kind of like a star pattern, if you will. Then you can go back through and circular snug them. And then for your spinner, and I always apply even still just a drop of Loctite, blue Loctite on everything, but for now things are just being kind of still dry test fit. That spinner, I would even be tempted to put a lock washer underneath it depending on how much space is there. But that, guys, is how easily and simple we can go ahead and install and drill a prop and align it. So this thing is looking better and better as we go. Super excited. Can't wait. Let's continue on. Now we're going to go ahead and throw in our spark plug. So here's a couple tips for you for setting spark plug gap. Do not drop your spark plugs on the ground. You should not use pliers. When you use sockets, technically you should use a rubber isolating socket on the inside, but for this little stuff, that's pretty hard to find or have. When you go to set spark plug gap, there's a couple different tools. So this something is really old school, and that measures in thousandths. And then you have something newer from like Snap-on tools that would have a metric on one side and then a thousandths on the other. There was no specifications for this in the book as far as what the spark plug gap should be. I did some searching around on the internet and found nothing. A lot of typical engines around the DA50-60 size are right about that 20 thousandths, so that's where we're going to check and set this. If you ever drop a spark plug for what the price of these NGK CM6s cost, I would just simply replace it. You don't know if you have cracked the porcelain and will have ignition spark jump or crossover or short, and it's not worth it. So try not to drop them on the ground. Now when you go to set this, always refrain from using the ramp and driving it between the electrode and the ground side of this thing. Spark plug tools checkers have these little tabs there, or in this case like that tab there, and all you're going to do is place that over that grounding tab and then just give it a little slight pry and try it again if you need to open it. If you need to go downward and close that gap a little bit, then all you're simply going to do is use something like this and then turn, and that will push down on that tab. Do not bang on the spark plug in order to close it, and don't wedge it in there and try and kind of pry it open between the electrode. That's bad for it. So our spark plug gap is set on this thing. We are going to go ahead and throw that spark plug in, start it by hand to make sure it doesn't cross thread, and you only need to tighten this up to the point where you crush and seal that gasket. It does not need to be super crazy tight because you are threading it into aluminum and you don't want to pull it out. Now when it comes down to your ignition wire is going to have that rubber boot in there. I typically take a little dielectric compound you can find at any hobby store or any automotive store, and simply place a small film on the inside of there. So dielectric film or dielectric grease is actually like an electrical insulator realistically, but we put a little bit in there to help reduce moisture and spark jump, but also to make it possible that after this thing's been cooking on that engine for a couple years to actually come off. I try and change my spark plugs yearly because they don't cost much and it keeps the engine running well. So we'll put a little bit of dielectric grease on there. We'll place that over the spark plug. We'll see where we're going to mount this ignition wire in respect to the cowling later, but for now I'll just keep it right there until we get a final tune on this engine. But otherwise we got our spark plug wire kind of set up here and ready to go. And there you have it, everybody. Thanks for joining me. Thanks for watching. I really appreciate it. Do me a favor, if you liked it, smash that thumbs up button. If you didn't like it, make sure you hit that thumbs down button twice for me. Like, share, subscribe, all that cool stuff. I really appreciate all you guys taking the time out of your day to watch. And as always, if you're interested in this balsa ARF or any others, do me a favor, head over to www.Gator-Rc.com and check out the full line of Warbird balsa ARFs that they have, as well as some regular conventional airplanes there as well. And I'm telling you, what makes ARFs cool, especially balsa ARFs, is it really comes down to customization. Your own servos, your own engine, your own AutoStart, your own cool stuff, just like we're putting into this one. So again, I wish you guys happy flights. Peace out.